हेलो एवरीवन, हाउ आर यू? आई होप यू आर डूइंग वेल और साथ में आप पढ़ाई भी कर रहे हो. तो इट्स नाइट एंड आई एम रिकॉर्डिंग लेक्चर फॉर यू. सो yesterday we discussed isochoric process and cyclic process, and we didn't discuss questions based on that. So today we are going to discuss some questions based on cyclic process and isochoric process. Okay, so let's read the first question. Oh, this is Mr. Antenna. You are Mr. Antenna or Miss Antenna. Okay, I won't do any partiality. Mr. or Miss Antenna, fix your antenna so that you can receive a signal. Okay. Now let's read the first question. A cyclic process ABCD is shown in the pressure versus volume diagram. Which of the following curves represent the same processes? Okay. So according to question, we have been given a pressure versus volume diagram, है ना? And we have been given a cyclic process here. And based on that, we have been given 4 options, and we have to mark the correct option, which is the correct representation of this given diagram, है ना? Okay, let's understand this. See, this type of questions are very easy. Okay, just you have to decode few points and you'll get the answer. If you see from A to B, right? Let's decode it from A to B. If you see, pressure remains constant, right? Pressure is constant. Okay, so pressure is constant. Okay, let's first eliminate the option. Pressure is constant A to B. If you see the first point. So let's see where I am seeing the same thing. Let's eliminate the option. Pressure versus temperature, I don't know. Again, volume versus temperature graph, I don't know. Here also VT graph, it's PT graph and it's PT graph. Okay. So from A to B, pressure has to remain constant. If you see third option, from A to B, my pressure is not remaining constant with temperature. So this option you can eliminate, है ना? First option गया. Now I have to choose 3 options. Okay, I need more few points. ठीक है? तो A to B we can understand. B to C it can be adiabatic or isothermal. ठीक है? And D to A it can be isothermal or adiabatic. लेकिन we don't need to go into that. Okay, let's decode it further. From A to B, pressure remains constant. अगर ideal gas equation if I apply here, PV equals to nRT. Okay, so pressure remains constant. V I can write nR by P into T. Number of moles constant, R constant, P constant. This entire value is some constant, right? ठीक है? So we can say V is equal to some constant into T, right? Number of moles, R, P, all are constant. ठीक है? So we can write V is some Ct. Means as my temperature will increase, volume will increase. As temperature decreases, volume decreases. Okay, now let's see first option. Okay, as my temperature increasing, A to B, my volume remains constant, but V has to be proportional to T. है ना? Here you can see V is constant as there is increase in temperature. So first option is also gone, है ना? Now go for we have 2 options, second and fourth option, है ना? If you see here, as my temperature is increasing, okay, from A to B, volume is increasing. Okay, so temperature increase, we can see volume is increasing. I can have second option, and let's see the fourth option, है ना? Pressure versus temperature. Okay, pressure versus temperature graph. Pressure versus temperature graph, if you see from A to B, my pressure remains constant. Okay, so I can also have second option and fourth option, right? From A to B, my pressure remains constant. So I need few more points, huh? Then only we can do better analysis. Okay, B to C will not touch, D to A will not touch because it's little bit complex to decode it, isothermal or adiabatic process. Lekin if you see from C to D, ठीक है? ये this was my isobaric, this is my isochoric, है ना? You can see it because my volume remains constant. ठीक है? So as my pressure decrease, volume remains constant, right? Here you can see as there is a drop in pressure, volume remains constant. ठीक है? Okay, let's use it. Apply ideal gas equation. PV equals to nRT. ठीक है? So there is a decrease in the pressure, and volume remain constant. So V I can write, P I can write nRV T. N constant, R constant, V constant. So we can write P is equal to some constant into T. है ना? Means if my pressure increases, my temperature also has to increase. Pressure decreases, temperature also has to decrease. But if you see in the fourth option, है ना? As my temperature, okay, is increasing, if I talk about C to D, right? We are talking for C to D. As my temperature is decreasing, okay, my pressure is remaining constant. You can see here, as there is a drop in temperature, according to this graph, pressure remains constant. But I have to have P proportional to T, right? So fourth option is also wrong. Second option is my correct answer. Clear? Okay, now let's move on to the second question. Okay? So second question padhte hain. Second question they have given, an ideal monoatomic gas is taken from state A to B, then from B to C, and finally back to state A as shown in the pressure versus volume diagram. Which of the following is correct for the BC process? Okay? So they have given pressure versus volume diagram for monoatomic gas. Okay, monoatomic, diatomic gas, it's not relevant here. Okay, in the question they have given, first we are taking from A to B, then B to C, then back from C to A, and these are the corresponding pressure and volume they have been given, and they're asking, they have given what will be the correct option, right? So correct option, if you see, we have to think about what is heat, whether it's positive, negative, change in energy, positive, negative, or work done, positive and negative, right? So let's work with that option, which is easy to first find, right? If you see work done, okay, they are talking from B to C, right? So if you go from B to C, if I go from B to C, B to C, B to C, right, there is a decrease in the volume. So when I go from B to C, you can see there is a decrease in the volume. If there is a decrease in the volume, we know that it's a case of compression. Okay, gas is being compressed, compression. If there is a compression, we can say work is done on system. If work is done on system, work done will be negative. Okay, some negative value. Okay, so if you see the option, first gone from the picture, second, okay, third is also gone from the picture. I can have first, second option or fourth option, है ना? Now let's talk about change in internal energy. ठीक है? To know about change in internal energy, I should be knowing the temperature. ठीक है? Temperature they have not given here. We have to check it. Okay. Let's say at point B, what are the variables we have? Volume is 5 V naught, pressure is P naught. So write P naught, volume 5 V naught, and let's say temperature here it's TB. I don't know that. Okay. Similarly at point C, pressure they have given 4 P naught corresponding to this, and corresponding to this volume we have as V naught. Temperature at C, I don't know, let's call it to be TC. Okay? If I get temperature relation between TC TB, we can check whether my internal energy is increasing or decreasing. Based on if temperature increases, internal energy change will be positive, temperature decreases, internal energy change will be negative. Okay? So check करते हैं. Let's check it TC and TB. If I apply ideal gas equation here, है ना, यहाँ पे PV equals to nRT. If I apply it here, okay, at C, can I write pressure there, that is 4 P naught, so 4 P naught, volume there V naught, number of moles, let's say gas, number of moles of gas I have is N, ठीक है, R okay, constant, temperature here it's TC, ठीक है, I'll call it first equation. Similarly यहाँ पे भी ideal gas equation you apply, PV equals to nRT, pressure here it's we have P naught, volume here we have is 5 V naught, number of moles same, R gas constant same, temperature TB. Let's call it equation number 2. अब ये दोनों का let's take the ratio. Let's take the ratio, we can get the comparison. So I can write equation 1 by equation 2. ठीक है? So we'll get 4 P naught V naught equals to nRTC divided by P naught 5 V naught divided by nRTB. ठीक है? nR cancel, P naught V naught cancel. Okay, so basically I am having 4 by 5 TC by TB. Okay, so TC by TB, if you see the ratio, okay, TC and TB, can I say TC is less than TB? है ना? TC is less than TB. We can see from here, we can conclude ना, TC is less than TB. You can take TC to be 4, TB to be 5. Okay? So TB is greater than TC, you can say. So if I am going from here, B to C, okay, B to C, there is a decrease in temperature. You can see, if there is a decrease in temperature, change in internal energy will be some negative value. है ना? Second and fourth option, if you check, fourth option I'm getting change in energy to be negative. Here they have given positive. So directly second option is wrong, fourth option is correct. ठीक है? अब चेक करना है डेल्टा क्यू के. इफ यू वांट टू चेक द साइन ऑफ व्हाट इज हीट, यू कैन यूज फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, है ना. फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स, you can use that. Okay. First law of thermodynamics says heat given will be equal to work done plus change in energy, है ना. So work done I have is negative, and change in energy I got negative. So negative plus some negative, I'll get negative value. ठीक है. So by that also you can say fourth option is correct. Okay. Okay, I hope you are enjoying the question. So let's move on to the third question. ठीक है. Third question पढ़ते हैं. In the figure given, two processes A and B are shown by which a thermodynamical system goes from initial to final state F. If delta QA and delta QB are respectively the heat supplied to the system, then okay. ठीक है, I'll read out the question. इसमें question, in the question they have given pressure versus volume graph they have given. ठीक है, and we are having two thermodynamic process. I'm going through process A and B from initial, I for initial, F for final. So there are two processes by which I am going from initial to final state along A and B. So they are asking, they have given four options and we have to check whatever the options satisfy the given figure in terms of heat, है ना. तो heat के form में we have to check. Okay, so I am going from initial to final point. Okay, if you see here, okay, let's talk about first internal energy. ठीक है, internal energy, change in internal energy. If you talk about internal energy, है ना, U is my internal energy. ठीक है, internal energy is a state function, है ना. ये state function है, means it only depends upon initial and final point, right? Means it depends upon initial and final point. Okay, if you see here, if I go along A or B, my initial and final point both are same. So can I say change in internal energy either along A will be equal to change in internal energy along B, because it depends upon initial and final point. So along both the process, my change in internal energy is going to remain constant. Simple. ठीक है. Okay, what else? If you see here, if I break this now, if I want to check the heat, I should be knowing about work done so that I can apply first law of thermodynamics. ठीक है. So if you break this graph, okay, let's break this graph into two parts. Pressure versus volume. Initial to final. If I go along process A, है ना, if I talk about work done, I have to find this area. Okay, this much area. Let's say this area is A1. So work done is given by area. Work is nothing but area under PB. Okay, so A1 work done, if I talk about from along path A, okay, I can write plus A1, because volume is expanding and area A1, whatever the area, I'll get positive work. Okay, this is first half. Second half, if you see, okay, if I go along B, initial to final, okay, again if I want to find work done along B, okay, I have to find the area, simple area. So I have to find this area under this graph. Let's say area is A2. So work done along B, it's nothing but area A2. Here also there is expansion, so volume expansion, so I'll have positive work done. Okay? Now if you see area wise, okay, I'll erase the question. Okay, I need a space here. Okay, so if you see here, work done along A, I got plus E1, and work done along B, I got plus E2. Now if you see area wise, A1 and E2, if you compare it, can I say A1 is greater than A2? means work done along A will be greater than work done along B. Simple. Now if I apply first law of thermo, okay, if I talk about this process along A, I can write heat along A will be equal to work done along A plus change in internal energy along A. Similarly, if I apply for B part, this is for A part. If I apply for B part, I can write delta Q along B equals to work done along B plus change in internal energy along B. Okay? Now if you compare this two, okay, subtract these two equations. Okay? Equation 1 or equation 2, subtract it. So can I write delta QA minus delta QB is equal to work done along A minus work done along B plus change in internal energy along A minus change in internal energy along B. Okay? Now we already got change in internal energy along A and B are same, है ना? इसको उठा के you put it here. So this term will be 0, है ना? So can I write delta QA minus delta QB, okay, will be equal to WA minus WB. Now WA minus WA is greater than WB. So can I write this is all in all some positive value, है ना? So this value I'll be getting some positive value. So QA minus delta QB, I'm getting positive value. So can I say delta QA will be greater than delta QB? Simple. Okay, so I'll be having fourth option. Clear? So like this we have to decode it and solve the question. I hope you got it. If you didn't get it, pause the question and try to go through it. Later on you see the solution. Okay. So keep on studying. All the very best.